so if all goes well, bless you. So if all goes well, you realize that this was a really, really quick and easy exercise to do, because you basically are going to do what? So I want to start at 0. I could start at -3. That would seem kind of weird though, right? So if I start at 0, what is the value of sine at 0? So I go here and I pick which value? I pick the y value, right? So would you all agree that sine of 0 is 0? Now what am I going to do? I'm just going to work my way around this thing, right? And pick the y values. So I have 0, then I have 1, then I have 0, then I have -1. And then where do I end up when I get back to the beginning? Back to 0. All right, so what if I went the other way? What if I started here and I went in the negative direction? I would go from 0 to -1 to 0 to 1 to 0. All right, cool. Now if I want to do the same exercise with cosine, I'm going to do what? I'm going to do the exact same thing I just did, except pick the x values, right? All right, so starting at 0, I have a 1, right? From 1 I go to 0, -1, 0, and 1. Or if I went the other way, because now I'm going in the negative direction, right? I would go from 1 to 0, -1, 0, 1. All right. So fair to say, everybody, that these aren't some magical values that I just pulled out of a hat, right? We see where they came from. Cool. Now what I'm going to do is this, guys. I'm going to take this information and I'm going to transfer it onto the coordinate plane. Okay? I'm going to transfer it onto the coordinate plane. Now what I have is this. I have two separate graphs that I'm going to do. Okay? I'm going to graph both sine and cosine. So guys, remember, when I graph something, what do I need? I need an x value and a y value. Okay? So I'm going to graph sine first. Okay, so at the x value of -2 pi, which is the same as -360, so where does that put me on my plane? It puts me here at -2 pi, right? So just think of this, guys. This is an xy coordinate grid, right? So for sine, where am I supposed to plot? At 0, which is what? On the x-axis. All right. And now from there at -270, which is the same as -3 pi over 2, I'm going to go to what? I'm going to go to 1. All right, let's put 1 right there. And then where am I going to go? Back to 0, right? Okay, so that's here. And then where? -1. And then where? Back to 0. And then where? +1. And then where? And then where? And then back to 0. So we get all these points, and they seem like they're haphazardly placed, but they're not. They're not haphazardly placed at all. Guys, does somebody want to tell me something about this graph? Well, is there a pattern? Definitely, right? There's definitely a pattern. Is this a complete graph? Ariel's shaking her head. No. Why not? You're right. Okay. Well, yeah. Okay. So you want me to connect the dots? I agree. I guess when I say complete, my question is: are there other values of x that we could have continued to graph? Yeah, because guys, could I have just kept going around my circle and plotting more and more points? Yeah, I could have, right? So how far out in the x directions will this graph go? Forever. I could just keep getting more and more points, right? By going around and around and around the circle, okay? Now, you guys said it. This is not continuous because I haven't connected the dots. What I'm going to do is I'm going to connect the dots with a smooth curve. So what it's going to look like is this. Anybody walk by one of Mr. Fuchsi's class or Mr. McKenna's class and see them playing with these, right? And what are they really doing? Anybody know what they're doing? They're playing with slinkies. That's exactly right. What they're actually doing, guys, and you're not gonna be able to see it, but Sam, come here for a second. So if he was to stand on that side of the desk, and I was to stand, grab the end, all the way to the end. Keep it on this here though. Keep it on the desk. All right. So if we did this, right, and I just had Samson sit there nice and still, and I started doing this. What are you noticing? What does it look like, dude? Yeah, right? If you guys want to see it, if you come up here, it looks exactly like what's on the board. It is a sine curve, okay? Now, it's a sine curve, right? And it looks just like this. And the faster that I move that, right? The faster that I move that, the closer and closer these things get. So instead of them being this far apart, I can actually squish them together, right? The slower I move it, the wider apart they are, okay? Guess what, guys, right? That is exactly how you can tune into the radio, okay? Radio frequencies, right? Radio waves are nothing more than sine curves, right? They're frequencies that are sent out. And guess what? The faster that I move my hand, right? The more compressed it is, the different frequency, right? Which is why you're able to change channels, right? So that's really what's going on here, right? Oh, look at that. You can talk about that when you go home. You can sound really, really smart, right? Smart. All right, so if we graphed cosine, okay, you're not going to be all that impressed when I do cosine because I think you're going to agree that you're going to get a very similar picture, right? Because don't we have that same sort of pattern going on? The only difference with cosine is instead of my graph starting at 0 at -360, this one started at 1. So I would start my graph here and then go to 0, -1, 0, 1, 0, -1, 0, 1. And my graph looks like this guy. Which I think we can all agree is basically the exact same graph. It just starts at a different value, doesn't it? Yeah. So if I asked you guys about domain, and I asked this question a few minutes ago, I said, guys, is this a complete graph? You said no, because I need to put some, don't put arrows. Do this, guys, dot, 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 dot. Because these things just keep going, right? These things just keep going, okay? So the domain is going to be all reals. And this says in interval notation. So all reals, which is the same as -infinity to +infinity, right? Now, next question, range. Range is what? Y values, correct? What's the lowest Y value in both of these graphs? -1. And the highest? +1. Yeah, the highest this graph goes is 1. The lowest it goes is -1. Even. Here's my y-axis, guys, right? Here's my y-axis. Is this graph symmetrical to the y-axis? The green one is, I'm sorry, is the green graph, does it have symmetry to the y-axis? It does, right? So cosine is an even function. And then, guys, here's the origin. Here's the origin. Remember, guys, how is a function odd? If this serves as a point of symmetry. So on the red graph, do you see how this point is a midpoint of this and this? Do you see how this point is a midpoint of this and this? And if you were to take your paper, guys, and you were to flip it upside down, does the green graph still look the same? It does, right? Yeah, so this is considered an odd function. So sine is odd, cosine is even. Really, 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 really important. I'm going to show you guys two repeating patterns, okay? Sine. There's the top of sine, right? Does sine have a bottom? It does, right? Would you agree that that is one cycle? I'm going to use the word cycle. That's one cycle of sine. Now, why is that one cycle of sine? Because isn't there a exact duplication of that pattern right there? And if I were to graph it again, I would graph another blue one over here, or another yellow one, because they're what? Same. Okay. How long does it take me to graph one? I'm going to use a new word. Ready? I'm going to use the word period. Okay. One cycle of this is a period. How long does that take? Well, this starts at -2 pi and it ends at 0. This starts at 0 and it ends at +2 pi. So how long is one period of sine? Well, 2 pi. 2 pi, yeah, 360, right? Because this started at 0 and went to 2 pi. This started at -2 pi and went to 0. So that's 2 pi space, right? Okay. Now, what if I looked at my green graph instead? So let me get rid of my highlight. And let me highlight my green graph for a moment. No, it's not going to let me do that. Go away. Yep. Go away, blue. Ah. All right, green graph. Here we go. There's a little portion, right, of my cosine curve. What does that portion of my cosine curve do? It starts at 1 and goes down, right? But then I got a part that goes up, right? Okay. But then what does my cosine curve do from there? It goes back down and back up. So wouldn't you agree that that yellow is just a duplication of that blue? Fair to say, right? So how long is one cycle of cosine? Still 2 pi, isn't it? Still took 2 pi, okay? So for period length, right? Again, period is how long it takes me to graph one pattern, right? And in this case, it's 2 pi, right? The period is 2 pi. And make a note, guys, that is the length required to graph one cycle. Cool? All right. Take a look at your notes, guys, and tell me which graph I have labeled here, or which graph not labeled, which graph I have plotted. Which one is that? Is that sine or is that cosine? All right, so this is definitely cosine. Where do you guys like to look to figure it out? Where do you like to look? Do you like to look all the way over here? Okay, don't do that. All right. Instead, what I want you to do is always look at the 0. Always look at the 0. If your graph starts at a value other than 1, if your graph starts at 0, it's probably going to be a sine curve. Okay. If your graph starts at a different value, it's probably going to be a cosine curve. So when I say starts, I'm talking about y. Okay. Talking about the y. All right, but this is cosine. I agree. What did I do differently in the 3 examples to the left? What did I do differently? What's there that wasn't there before? A value in front. A value in front. Hey guys, if I was to go back to the previous page, you all agree that this value right here, let's use this one. This value right here. We all agree that sine of 90 is 1. Is that fair to say? Well, guys, if I put a 5 in front of sine, and I said, what is 5 sine of 90? Anybody want to venture a guess what you would have to do to 1? Multiply it. So what would this value be? 5. Well, if sine was equal to 0, what would 0 times 5 give you? 0. Well, if this value was -1, what would -1 times 5 give you? -5. So if there's a number in front, all you're going to do is take the numbers that you would have in this chart and simply what? Multiply by that number. Cool? Well, in this case, I want to graph this one in red. Okay? Well, what is the number in front? The number in front is 3. Guys, isn't this a graphical representation of our chart? What is the y value? Listen to the question. What is the y value right here? How high am I? I'm at 1. So if I multiply it by 3, where am I going to be now? At 3. 1, 2, 3. Okay, what is the y value right here? How high am I? At 0. What's 0 times 3? 0. Okay, what's the y value right here? -1. Where's it going to move? To -3. This is 0. 0 times 3 is 0. This is 1. 1 times 3 is 3. And does everybody see that I've created one cycle? That's one pattern of cosine, right? And then it's just going to duplicate. Connect the dots. And there's my graph. Let's label it 3 cosine of x. Ariel, notice something really important here. The period for the original graph was 2 pi, correct? Well, isn't the period for one cycle of this also 2 pi? It didn't take any longer to graph it, did it? But the height has changed, hasn't it? Okay. Anybody want to venture a guess what I'm going to do here? This says -4. Well, I'm going to take my original curve and multiply by -4. Let's do this one in green. So what is this point on my original curve? 1. 1 times -4 is -4. So I'm going to go down to -4. Okay, this is 0. 0 times -4 is 0. This is -1. -1 times -4 is +4. And then 0. And then -4. Here's one cycle, right? Can somebody give me a really, really astute comment from a really, really smart student? What's a really, really astute comment that somebody might make? They agreed. Agreed. I only graphed one cycle, by the way, right? I still need to graph the other one. But what do you guys notice about the green graph? It's been, well, it's definitely been stretched, no doubt about it. Thank you. Say it again, Aiden. Yeah, guys, this negative sign right here reflected our graph over the x-axis, didn't it? Just like our CBAD graphs did earlier this year, right? The A value still does a vertical reflection, right? So if that A value is negative, it still does it. So this is a reflection over the x-axis, right? It's a reflection over the x-axis. All right, let me graph my other cycle here. My other cycle, boom, boom, boom. All right, and that we said was -4 cosine of x. You guys doing okay? Not too bad, right? Guys, I'm going to ask that we don't do this next one, only because I don't want to like put too much in here, and if you go back and look at it, it's going to be a mess. The only difference, guys, is instead of multiplying by 3, instead of multiplying by -4, you're going to multiply by 1.5, right? So it's okay. 1.5 would just put me between 1 and 2. All right, so is that a problem? No. Guys, new word. Ready? New word. The word is, please circle it and star it. The word is amplitude. And all I want you to remember, your teachers have taught you this word in a terrible way over the years. Actually, your teachers have never taught you this word, so I'm not going to do the terrible way. In the past, teachers have said that amplitude is the height. Ugh. Amplitude is half the height. Amplitude is half the height. So if I asked you, how tall is the red graph? Well, when I ask you how tall you are, you measure you from your feet to your head, right? Well, how tall is the red graph? The lowest point is -3. The highest point is +3. So the red graph is 6 units tall. But the amplitude is half the height. So what's the amplitude? 3, okay? So when you look at this, guys, isn't this number right here the amplitude, right? Now be careful with that because I sort of misspoke. Can something ever have a height of -4? No, so what would you say here? The height is 4, it's just been reflected, okay? So when I ask you for an amplitude, you're gonna give me one of two things. you're going to look at this number and you're going to give me the absolute value of it, or you're going to look at your graph, you're going to tell me what half of its height is. Make sense? Okay, you guys got the difference between the two, right? So, looking at this graph, right? What is the height of this graph? Height. How tall is it? How tall is it? 2. So what's the amplitude? 1. And that makes sense because isn't this just an example of sine? What's the number in front of sine? A 1, because what's there? Nothing. Okay? Take a second, guys, and hi, good morning. Take a second, guys, and all I want you to do is graph this one and graph this one using the same techniques that we did on the previous problem. All right, I'll graph it with you guys. So what am I going to do here in my red graph? I'm just going to take all my values of y and multiply them by 2, right? So my red graph, is that okay? All right, for the red one. And then what am I going to do here for the blue one? Well, this point doesn't move, does it? My blue graph, instead of going to 1, is going to go to -3. So it's going to go down, right? It's going to go the opposite direction. Going to look kind of like this guy. Boom. And there you have it. Again, you know, these, let me stop here.